So now we're going to be using KSP for problems number 7 and 8 on your classwork. I hope you've already tried to work them on your own before we work them together. Let's get started. So this question is asking, will 0.50 grams of PbCl2 dissolve in 1 liter of water at 25 degrees? So since this question is asking, will 0.5 grams dissolve in a liter, the first thing we need to do is figure out how many grams will dissolve in a liter, and then see if it's greater or less than 0.5 grams. So let's start with the KSP expression. KSP is equal to the concentration of Pb plus 2 times Cl minus squared. Since there's a 2 in front, that 2 gets used for the square. And since the PbCl2 is a solid, it gets ignored completely in the KSP expression. So now that we have the KSP expression, we're going to write the icebox and then solve and see if we can plug things in. So initially there's some amount of PbCl2 solid, it doesn't matter how much. There's 0 Pb plus 2 aqueous and 0 Cl minus. So the change, the PbCl2 will dissolve some amount X, I'm not sure exactly how much. Pb plus 2 will gain that same amount X, and Cl minus will gain twice that much, or 2X. So that at equilibrium, we have X and 2X. So now all we have to do is plug these numbers into our equation, along with the KSP value from your chart. The KSP value from your chart should be 1.6 times 10 to the negative 5, and that'll be equal to X times 2X squared. And remember that 2X quantity squared is the same thing as 4X squared. 4X squared times X, so we have 1.6 times 10 to the negative 5 equals 4X cubed. So first thing we're going to do is divide both sides by 4 so that the 4 will cancel out, and we end up with 4 times 10 to the negative 6 equals X cubed. Next thing is the cube root of both sides. That way the cube will cancel, and we get X equals 1.59 times 10 to the negative 2 moles per liter. Okay, 1.59 times 10 to the negative 2 moles per liter is the same thing as 0.0159 moles per liter, but it's asking, will 0.5 grams dissolve? So I need to change this moles per liter into grams. 0.0159 moles per liter. 1 mole, again we're talking about PbCl2, so that's 207.2 plus 35.5 plus 35.5. I have 2, 8, 7, and 278.2 grams. And that is 4.42 grams per liter. So what this means is 4.42 grams will dissolve in a liter of water. So the original question, will 0.5 grams dissolve in a liter of water, is yes. Because 4.42 grams will dissolve in a liter, definitely 0.5 grams will dissolve in a liter. Alright, next problem. How many grams of AgBr are required to make 500 milliliters of a saturated solution at 25 degrees? And they've given us the beginning half of that equation. So AgBr solid should make Ag plus aqueous and Br minus aqueous. Hopefully as you were working this problem it looked really familiar, because this is the same exact example as we had on number 5. So I'm going to go through it kind of quickly now, but if you need a refresher, just go back and watch the video for how I worked out number 5. So we have a KSP expression. That is Ag plus times Br minus. In your icebox we had X here and X there, so we ended up with 4.8 times 10 to the negative 13 equals X squared, or X equals 6.9 times 10 to the negative 7 moles per liter. but it's asking us about how many grams of AGB are, so we need to change this into grams. Again, we also changed it into grams on number 5, so you can check there. So 1 mole is 187.8 grams, and if you multiply that out, you get 1.3 times 10 to the negative 4 grams will dissolve in a liter. So 1.3 times 10 to the negative 4 grams is how many will dissolve in a liter. But this question is asking how many grams of AGBR are required to make 500 milliliters of a saturated solution. So 500 milliliters, that is 1 liter for every 1,000 milliliters, so that's 0.5 liters. So all we have to do is take this number, multiply times 0.5 liters, so that the liters cancel out. Essentially, it's the same thing as 1.3 times 10 to the negative 4 divided by 2, and you get 6.5 times 10 to the negative 5 grams will dissolve in half of a liter. Excellent. Now we only have one problem left.